We finished this first section with a discussion of literal equations. Now, a literal equation means it's an algebra equation filled with letters instead of letters and numbers. And so, for example, what if you had y equals 2 mx plus b? That's something you've all seen before, the equation of a line, where m is the slope and b is the y-intercept number. What if we wanted to solve for x? Alright, so I'm going to pick on x and isolate x. Well, here's an example of a literal equation. And in fact, they're just letters, only letters. So if you're going to take more math, you have to get more and more used to this, working with symbols. And because working with symbols like this, with the letters, is working in a greater generality. And in a sense, this is how we develop some formulas. We have to solve an equation with a bunch of different letters in it to get formulas that are useful, for example. So what I like to tell students is that, well, all right, here we're going to solve for x. So I'm going to pick on x. That's my variable. The other letters are just numbers. They're just constants. So in other words, I'm going to treat y, m, and b as if they're just ordinary numbers. They do represent real numbers. You see, so because they are real numbers, they obey the same rules as just regular numbers. So how do I solve for x here? I'm going to begin by isolating the x term by subtracting this constant number b. So I'm going to subtract b from both sides. And on the left side, what do I have? I have y minus b. And here the b's canceled. So I have m times x. So, I treated b as if it's an ordinary number. Now the difference between this and a regular equation is that I can't combine these numbers together. And so I can't combine y and b because I don't know what they are specifically, so they are unlike terms. But so that's a little difference. Now to solve for x, I need to, well, what's m do? M is multiplying x, so I need to do the opposite. I need to divide by m. So there's that idea of opposite again. We use opposites to solve equations. So we can divide both sides by m. The m's cancel. And let's write our answer. Again, we solve for x. So x equals to, I'll put x on the left, y minus b over m. And there you have it. And so that solved that equation. So whatever you do, don't panic. Okay, it's just algebra, and there's really nothing very new with this type of problem. We're still moving things around, just like you do when you first learn algebra. The only small difference is that they're not all just numbers now. So again, if you take a lot more math, you're going to appreciate this kind of discussion because more and more you begin to work in symbols and generality rather than specific problems. All right, well, I'm going to erase the board and put up one more example for you. This literal equation has a little bit of a twist to it, and I always like to work an example similar to this one. There's one in my book also, which is actually an actual formula that's used in the study of optics. The study of like lenses and eyeglasses and binoculars and those kinds of optics issues. There's a problem in my book which uses a formula kind of similar to this. All right, I'm going to solve for this time for letter C, and it's 1 over a equals 2 over b plus 3 over c. And so, well, what do? Well, here's the wrong thing to do. All right, the unthinking student will just invert both sides. So this would be definitely wrong. All right, you do something like this, you'll get 0 credit from me. I can't just flip both sides. Get a over 1 equals b over 2 plus c over 3. Okay, it does not work. If the right side was a single fraction, I could do that. If you have a fraction equal to a fraction, just one on each side, you can flip both sides. That would be okay. But you can't invert 2 over b plus 3 over c and get b over 2 plus c over 3. it will never work. All right, so don't try it. Don't try it. I know it's tempting. All right. Well, there are a couple ways to do this. I'm going to approach this like we did our other rational equations. I'm going to find the common denominator, multiply through, and that will cancel the denominators. So what is my common denominator? I have A, B, and C as my terms. So ABC is the common denominator. So we'll multiply each of these. And here the A cancels, there the B cancels, and there the C cancels. And that gives us 1BC, just BC, equals to 2AC plus 3AB. All right, now what was our original objective? Was to solve for C. And I have C's in two places. All right, so if I'm going to get C by itself, I need to bring the C terms together. So I'm going to subtract this term so it comes by itself over here. So if I subtract 2AC from both sides, I'll have BC minus 2AC equals 3AB. Now that was progress because, again, we're trying to get C by itself, so I do have C's on one side of the equation. I have a C in this term and a C in that term. Now what might that remind you of? Okay, I hope it reminds you of factoring. C is in common with each term. I can factor a C out. And so if I do that, I get C parentheses B minus 2A equals 3AB. All right, so now I'm down to 1C, and how am I going to get rid of this? Well, this parentheses is multiplying C. So I get rid of it by doing the opposite. I divide. Divide both sides by the parentheses, B minus 2A. So I end up with an answer, C equals to 3AB over B minus 2A. There we go. So it's done. I don't know if it looks, easier when you watch me do it. So this is a pretty hard step to think of on your own, and so I always like to show a problem like this because it's a little bit of a stretch to think, well, if I factor the C out, then I can finish isolating it. That's the idea of this problem here. All right, so in all these steps, and same with the previous problem, I didn't violate any rules of algebra. I did the same solving steps as that you're accustomed to with other problems. We subtracted the same terms from both sides. We multiplied by the same numbers. We divided by both sides by the same terms. And so none of the rules of algebra were violated in solving these literal equations.